Hello everyone. BSED Math 3 of CSAP is here for you. For today's video, the BSED Math 3 students of CSAP are going to teach you on how to solve for the determinant, minor, cofactor, adjoint, and inverse of a 3x3 matrix. Without any further ado, let's start.
Determinant. To find the determinant of a matrix, first of all, the matrix must be a square matrix, which means that it has the same number of rows and columns. Then it is just basic arithmetic. Determinant of a matrix can be denoted as like this, or absolute value of A. In working with a 3x3 matrix, we should simplify it into a 2x2 matrix. If we have a matrix A having the elements of A, B, C, D, E, F, G, H, and I, first, we will use the elements in the first row, this A, B, and C, as a scalar of our 2x2 matrix that will be formed after crossing out the corresponding rows and columns specified to the element. So, for determinant, we will use this form. So, we will use first A as the scalar. So, A is in row 1 and column 1. So, we will cross out the row 1 and the column 1. So, the remaining elements there is E, F, H, and I. Then, minus, we will use minus because we will use the positive, negative pattern. Okay, next is B. B is in row 1 and column 2. So, we will cross out the row 1 and the column 2. So the remaining elements D, F, G, and I. Next is we will use positive, and then we will use the last scalar, C. C is in the row 1 and column 3. So we will cross out row 1 and column 3. So the remaining elements are D, E, G, and H. We know that in determinant of a 2x2 matrix, like A, B, C, and D, we will multiply AB minus the multiplication of B and C. So in here, this is already a 2x2. This is also a 2x2, and this one. So we will simplify it. E times I minus this one, F, H. Next, negative B, DI minus FG. Plus C, DH minus EG. So, this will be our formula for getting the determinant of a 3x3 matrix. When you use this formula, you can substitute the given corresponds to the element in the formula. However, the best way is to memorize or master the pattern in solving the determinant. Let's have for an example. Matrix A is having the elements of 2, 3, 2, 1, 1, 1, negative 1, 2, and negative 3. So first, we will write determinant of A. The first row will be our scalars, so we will use first 2. 2 is in the row 1 and column 1, so we will eliminate or cross out the first row and then first column. So the remaining elements there are 1, 1, 2, and negative 3. So the next scalar or our B here is 3. So we will use negative because of positive negative pattern. So we will cross out the corresponding rows and columns of 3, which is row 1 and column 2. So we will cross out the first row and the second column. So the remaining elements there are 1, 1, negative 1, and negative 3. Next. Okay. The next and the last scalar will be 2. So we will use positive 2. Okay. Positive 2 here is in the first row and the third column. So we will eliminate or cross out the first row and the third column. So the remaining elements are 1, 1, negative 1, and 2. So now let's proceed by using our knowledge in finding the determinant of a 2 by 2 matrix. So we'll copy 2. Determinant of this matrix, 1 times negative 3 is negative 3, minus 1 times 2 is positive 2. Copy 3. 1 times negative 3 is negative 3, minus 1 times negative 1 is negative 1. Copy positive 2. 1 times 2 is 2, minus 1 times negative 1 is negative 1. So we will simplify this. Copy 2. Negative 3 minus 2 is negative 5, minus copy 3. Negative 3 minus negative 1, so this will be negative 3 plus 1, which is negative 2. Copy positive 2. 2 minus negative 1 or 2 plus 1 will be positive 3. 2 times negative 5 is negative 10. Negative 3 times negative 2 is positive 6. 2 times 3 is positive 6. So determinant of A equals negative 10 plus 6 plus 6 is positive 2. So now the determinant of a matrix A is 2.
In determining the minors of a matrix, we're going to find the determinant by deleting or eliminating the rows and columns in which the element lies. So we have here our given example. So based on our discussion earlier with this formula, we're going to find the minors of all the elements. So first we are going to find the minor of 2, which is M11. So it is located in the first column and the first row. So we are going to eliminate the first column, the first row, and we have the remaining elements, which are 1, 1, 2, and negative 3. And we are going to multiply 1 by 3. So 1 times 3 minus 1 times 2. So we have negative 3 minus negative 5. Next is we're going to find the minor of M12, which is 3. So we are going to eliminate the first row and the second column. So our remaining elements are 1, 1, negative 1, and negative 3. So we have to multiply 1 by negative 3 minus 1 by negative 1. Plus we have negative 3 minus negative 1. Negative 3 minus negative 1. So we have negative 2. We have negative 2 in our minors. 3. Next is we have M13, which is the element is 2, in which it is located in the first row in the third column. So we are going to eliminate the first row and the third column. So our remaining elements are 1, 1, negative 1, and 2. So we are going to multiply 1 by 2 minus 1 by negative 1. So we have 2 minus negative 1. So 2 minus negative 1 is equals to positive 3. So we have 3.
Okay, find the minor 2, 1, row 2, column 1. Ang mabili niya kay 3, 2, 2, and negative 3. Multiply equals 3 times negative 3 minus 2 times 2 equals 3 times negative 3 equals negative 9 minus 2 times 2 equals 4 equals negative 9 minus 4 equals negative 13. Find the 2, 2, row 2, column 2, 2, 2, 2, row 2, column 2. Ang mabili niya kay 2, 2, negative 1, negative 3. Negative 1, negative 3. Okay. Multiply 2 times negative 3 minus 2 times negative 1. 2 times negative 3. 2 times negative 3 equals negative 6. Minus 2 times negative 1 equals negative 2. Negative 6 minus negative 2, negative 6, equals negative 4. And find the minor of 2, 3, 2, 3. Row 2, column 3. Mabili niya nga number is 2, 3, negative 1, 2 times 2 times 2 minus 3, negative 1. 2 times 2 equals 4. 3 times negative 1 equals negative 3. Equals 4 times negative 3. 4 minus negative 3 equals 7.
Next, we are going to find the minor 3, 1. First, we are going to eliminate row 3, column 1. And the remaining elements are 3, 2, 1, 1. Next, we're going to multiply 3 times 1 minus 2 times 1. So 3 times 1 minus 2 times 1. And the answer is 1. So our minor 3, 1 is 1. Next, we are going to find the minor 3, 2. Eliminate row 3, column 2. So our remaining elements are 2, 2, 1, 1. Multiply 2 times 1 minus 2 times 1. So 2 times 1 minus 2 times 1 is equals to 0. So our minor 3, 2 is 0. Next is our minor 3, 3. We eliminate row 3 and column 3. So remaining elements are 2, 3, 1, 1. Multiply 2 times 1 minus 3 times 1. So 2 times 1 minus 3 times 1 is equal to negative 1. So our minor 3, 3 is negative 1. Therefore, our minor of matrix A is equals to negative 5, negative 2, 3, negative 13, negative 4, 7, 1, 0, negative 1.
Finding the cofactor of a matrix. Cofactor is defined as a sign minor. For finding the cofactor of a matrix, we have a formula of Cij equals negative 1 raised to I plus j multiplied by Mij. So, we already know that the minors of a matrix A is negative 5, negative 2, 3, negative 13, negative 4, 7, 1, 0, negative 1. Next, we apply the formula. Cij equals negative 1 raised to I plus j multiplied by Mij. C11 equals negative 1. 1 plus 1, the value of m is 1, so which is negative 5. So multiplied by negative 5, so equals negative 5. So C12 equals negative 1 raised to the power of 1 plus 2, and the M12, which is negative 2, multiplied by negative 2 equals 2. So C13 equals negative 1 raised to the power of 1 plus 3, and the M13 is 3, so multiplied by 3 equals 3. C21 equals negative 1, 2 plus 1, and the M is 2, 1 is negative 13, multiplied by negative 13 equals 13. C22 equals negative 1 raised to 2 plus 2, and the M22 is negative 4 equals negative 4. C23 equals negative 1 raised to the power of 2 plus 3, and the M23 is 7 divided by 7 equals negative 7.
Next is our C31 is equal to negative 1 raised to the power of 3 plus 1. Then our value of M31, which is 1, multiplied by 1 is equal to 1. Then our C32 is equal to negative 1 raised to the power of 3 plus 2 multiplied by our M32, which is 0. then our answer is 0. Then our C33 is equal to negative 1 raised to 3 plus 3 multiplied by our M33, which is negative 1. It is equal to negative 1. So our answer would be negative 5, 2, 3, 13, negative 4, negative 7, 1, 0, and negative 1. This is our cofactor of our matrix A.
Finding the adjoint of a matrix. Adjoint of a matrix is called the adjunct of a matrix. Is defined as the transpose of the cofactor matrix of the particular matrix. To find the adjoint of a matrix, first, find out the minor and cofactor matrix. So based from the answer earlier, the cofactor of a matrix A is equals negative 5, 2, 3, 13, negative 4, negative 7, 1, 0, negative 1. So to find the adjoint of a matrix from the word transpose. So our first column, it will become a first row. It will become negative 5, 13, and 1. So our second column, it will become the second row. So 2, negative 4, 0. And the third column, it will become the third row. 3, negative 7, and negative 1. So this is our adjoint matrix A. Matrix A.
We know that the determinant of matrix A is equal to 2. And we already have the adjoint of a matrix, which is the elements are negative 5, 13, 1, 2, negative 4, 0, 3, negative 7, and negative 1. So now we can solve the inverse of matrix A. The inverse of matrix A is denoted as A raised to the power of negative 1. Now the formula of the inverse matrix is A raised to the power of negative 1 is equal to 1 over determinant of A times adjoint of A. So we substitute the determinant of matrix A and the adjoint of matrix A. So A raised to the power of negative 1 is equal to 1 over 2 times negative 5, 13, 1, 2, negative 4, 0, 3, negative 7, and negative 1. So 1 half times negative 5 is equal to negative 5 over 2. 1 half times 13 is equal to 13 over 2. 1 half times 1 equals 1 half. 1 half times 2 equals 1. Negative 4 times 1 half is equal to negative 2. 0 times 1 half equals 0. 1 half times 3 equals 3 half. Negative 7 times 1 half equals negative 7 half. Negative 1 times 1 half is equal to negative 1 half. So therefore, the inverse matrix of A is equal to 5 over negative 5 over 2, 13 over 2, 1 half, 1, negative 2, 0, 3 halves, negative 7 over 2, and negative 1 half.
Before you will end this video, please give us a like, do subscribe, and click the bell button for more updates. Thank you.